It's HYLN video time, and in this video I'll take a look at guesstimating, or throwing some wild guess out there as to how long it would take to create these parts based on the minimum amount of information that's out there. But after listening to the Q&A some more, there's an additional piece of information that they did provide. But one thing we do know is that there's multiple printers at their facility.
Different sizes, different scales, as well as different speeds.
They also provided a video of the first generation of the Equilibrium additive printer printing a Carnot part for about, I would say, 10 seconds or so in this video. A new piece of information from listening to the Q&A is a rough estimate or a minimum number of these new generation of printers that they'll be receiving in 2025. Not all at the beginning of the year, but they'll slowly be acquiring them throughout 2025.
As Thomas mentioned, it's more like several dozen units next year versus a couple dozen units. So we're going to be taking delivery of units of additive printers throughout next year. So that's going to continuously grow our capability. So you have to think about it as the capacity that we'll have at the end of next year is more than 3 dozen units.
He finally spits out a number. So we can say there will be at minimum 36 of these new generation printers. It could be 48, it could be more than that, but at least at minimum, we can say that they'll be accumulating at minimum 36 of these new generation printers. And one thing, as they go from generation to generation,
we actually have 3 different models of printers that we're putting in our facility here in Austin, and they're different generations. Think of each one being the successor to the previous generation. And another way to think about them is each generation is probably 2 to 3 times faster.
The second generation will be at minimum twice as fast as the first, and the third generation, which would be the latest, would be at minimum 4 times as fast as the first generation.
Taking a really complex, maybe think of it as like a highly latticed structural component.
But here's a cutaway of the inside, and you can see, that is extremely complex, right? You could only unlock that through additive manufacturing. You couldn't even make that through conventional practices.
They're showcasing these very complicated parts.
Maybe something like a heat exchanger that requires high surface area by definition. You can see these massive implications about the input geometry, the complexity, and the effect that it has on my total price at the final tally.
It sounds like they don't have a choice. They have to print these very complex and complicated parts because that's what they have to do to achieve maximum efficiency.
If you think about it from just a pure kind of visual perspective, the part complexity determines the exposure element assignment for each layer. So in the case of like a DMLM process, this will be true for really any powder bed type process. The complexity, the geometric complexity per layer is actually the thing that's driving the amount of time it takes to process.
Now, I hope it doesn't really take that long to create a layer, somewhere between 20 and 30 seconds. In the video that I made note of at the beginning, it played for about 4.4 seconds of these lasers creating one layer of a Carnot piece. But there's an unknown part that has to be factored in as well.
So we have these 2 examples here. We have a green object that's on the left-hand side. This is a much more complex geometry. So you would know this kind of intuitively. You look at it, it's kind of a bulk in the middle, and then it has a bunch of little tiny maybe a compound radius curvature to it. And on the right, we have this red, simple, almost donut shape. The people with great eyes are going to see there's a couple little notches up in the top, but that level of complexity is by far simpler than what we're going to see on the left-hand side. So if you look at just the raw numbers, 32 seconds to generate this complex geometry on a layer basis versus 23 seconds for the simple geometry. So, in the grand scheme of things, 10 seconds, does that really add up? Well, if you have thousands of layers.
Yeah, it depends on the size of the part, but we will normally have 5,000 or so layers at a thickness of 20 to 100 microns per layer.
And you're running multiple machines across an entire year where you have a lot of availability, that adds up very quickly. And that can be one of the contributing costs. So, sometimes it's a little bit of a trade with additive technology. Do we go with something that's really complex?
They don't have a choice. They have to print something complicated because it's a heat exchanger and they want the maximum efficiency out of this generator.
And do we get our derivative savings, for example, if we go with something that's more complex? Maybe it performs better. Maybe it's much lighter and I know exactly how to do that cost trade. But adding complexity just for the sake of using something complex that looks quote-unquote additive, it may not be in your best interest. And in some cases, it's actually better to simplify a geometry in order to converge on a winning business case.
It's better to simplify a geometry to converge on a winning business case. They can't simplify it. So when you ask them, how long does it take? It's a moving target. It's very complex. There's a lot of levers we can push and pull.
So then the unlock here is, we talked about speed earlier. So how do you get these machines to be faster, or what has happened to make them faster?
Yeah, it's all wrapped up around really two things. One is the design and the other is the machine.
The design's complicated. Can't do much there. What about the machine?
And so from the machine perspective, it's how much energy can you put into that weld at any given time. And so we can get energy by both higher laser power as well as more lasers working together simultaneously on a part.
And whenever we see a machine change, I ran these same numbers with two lasers instead of just one. And that, obviously led to a substantial increase in my productivity as well.
And that's what they're doing. They're bringing in these faster machines with more power, more laser, more area, I guess you can use to create these additive manufacturing parts.
And the machines over the years, you've seen that progression of more lasers, higher power, and then we take advantage of that through our material properties. And then from the design perspective, it's really only using, again, the material that you need, so you're not wasting time melting components that you don't need, but also using the energy effectively. We nest parts, or we sometimes have multiple parts print simultaneously, and that helps reduce the cost.
One important phrase that he used is nesting parts.
We nest parts.
Nesting parts means it's kind of like similar to if you're going to bake cookies in the oven. You're not going to bake one cookie at a time. You're going to put multiple cookies on the baking sheet and cook them that way because it's faster. Taking a look at the minimum amount of time it would take to create a 200 kilowatt Carnot generator. And for example, these are three of the parts that you need to create a Carnot generator. And if you had three of these super fast 4x speed machines, and we're just generating 8 parts of each type, and keep in mind that the shaft has 2 parts and then there's 4 shafts, so you need a total of 8. It would take, and this is assuming if you're making them one at a time sequentially, it would take approximately, based off of what we know, at minimum 1.55 days to create one, assuming that everything, it's a sunny day scenario, everything went through fine. But then there's also the unknown part, which we can't see the machine printing the rest of the parts. So there's this, it's going to be 1.5 days plus Y, which Y is some unknown variable. Now, if they choose just to print the two most complex parts because they have to, they have no choice, and get rid of the simple one because they mentioned that in a video.
And reducing the number of additive parts by transitioning select less complex components to conventional manufacturing.
You now have two parts, and now you can allocate more machines because they have 36 of them. So in the first scenario, you had 3 parts, 36 machines. 36 divided by 3 is 12. If you remove a part, you have 36 machines divided by 2, produce up to 18 200-watt Carnot units in about a day and a half. Plus, there's this unknown part which would add more time to it. I don't know how many more days it would take to create a part, but you have to think about that as well. But if you go back to what Josh Mook said with nesting of parts, if you're baking those cookies and if you choose to create multiple parts per machine, like for example with 4 parts, if these new machines, they have that light flash, which I don't know because I haven't seen a video of these things running. I don't even know what these type of machines are exactly, but if you can like remove that by a factor of 5,000, because there's 5,000 or so layers, it's going to drop the time from a day and a half. It basically slashes it in half to about 0.769 days to produce a Carnot generator, plus some unknown quantity of time, which is about that number. So if I pull out a calculator here, and if I have 1 divided by that number, for about each 8.63 additional seconds it takes to create a layer, going to add a day to the build time. Again, that's assuming a sunny day scenario, which won't happen. I'm sure that these things will run at 70 to 80% of their maximum capacity. But yeah, that kind of gives you an idea of, plus they can also like get rid of the least complicated part, which it sounds like they may do, but it could be, they could decide on these 3 and there's some other unknown additive manufacturing part, like the outside casing. They could choose, oh, we're not going to do that. We're just going to move that part to general manufacturing. You don't know. You just can guess at this point, but it looks like if they could squeeze 4 items in there, which is a guess, it's going to take about 3/4 of a day plus an additional day for each 8.6 seconds that laser would have to run to create parts for the Carnot generator. That's it for this video, and of course, thanks for watching.